Hello, welcome to the day 2 lesson, Angles and Postulates. Let's go ahead and get started. What I want you to do first is take a moment, write these down on your worksheet somewhere on your guided notes, and try to answer them. I'm going to pause the video now. When it plays again, you will see the answers. So here are the answers. Look them over and double check, see if you got any wrong. If you did get one wrong, please make sure you ask about it in class. Now, this type of question, sometimes, always, and never, is a very common type of question you'll be seeing throughout the year. When you're doing these questions, make sure you're reading very, very carefully and that you understand what the question is asking of you. Best strategy for these types of questions is to know your definitions really well, because most of these questions will have something to do with definitions. All right, again, if you got one wrong, please make sure you ask in class, but here we go, on with the rest of the lesson. So this lesson will be about angles, primarily, and a few postulates that are associated with angles. So when you have an angle is actually created by two non-collinear rays. Now, if you had two collinear rays, then most likely you would end up with something like this or something like this. So if ever you're asked about two collinear rays, those are your two options. But two non-collinear rays make up an angle and have a common endpoint of a vertex. So the two rays that create this angle would be ray AB and ray AC. Or you can write ray AD. But make sure that you have the proper notation, that A, which is my endpoint and my vertex, is at the beginning of all of these rays. Now the vertex is the common endpoint. Shouldn't be a big surprise to anybody. Now we name angles as long as the endpoint is in the middle. It doesn't matter which side you start with, but you name endpoints by going from one side of the angle to the other side. So I have angle BAC. I have angle BAD or angle CAB. Doesn't matter if I start on this side or on this side. As long as my vertex is in the middle, it's the exact same angle. Make sure that your vertex is in the middle. Order matters in that one regard. If it's not in the middle, it's not the same angle. Another way you can name this angle, sometimes there will be little numbers, and you can say this is angle number 1. Okay. In this case, since our angle is all by itself, it's not attached to anything, you could also call it and name it by its vertex. Angle A. All of these work. However, this one, I'll write it in red so you can see it. This one you only use when it's not attached to anything. Right. And the reason for that, ran out of room. The reason for that is as we get further along, or you can even see it coming, as we get further along with different problems, different angles will all have the same endpoint. In which case, you need to know which angle you're talking about. You can't just use the vertex. All right, let's go ahead and move on. Now, something particular about angles, just like segments, you had the segments and then you had the segment measure. Well, angles also have angle measures. And what that means is the degree of the angle here in the corner. So in real life, you can use a protractor to measure angles and degrees. You've probably seen this before in all of your school supplies. But the way you read this, there are actually two different ways to read it. So you always start from the baseline. So this bottom line down here. Always start from here, and then you would look up. But as you can see, there are two different sets of numbers, an outer one and an inner one. If it's a smaller angle, if it's an acute angle, and we'll go over those names a little later, if it's an acute angle, you are looking at these numbers in here. So the angle, the measure of this angle would be about 72. So this angle is This angle is 72 degrees. However, if you were to have an angle on the other side, and let's say it goes right there, this green angle, well, this is an obtuse angle, and you would measure it using these outer numbers. So you always start from the bottom, but depending on if it's acute or obtuse, depends on whether you use the outer set or the inner set. So this one would be 160 degrees. And these are the measures of angle. So measure of angle means there's actually a numeric value that talks about the degree of the angle. And as we get into this next slide, the definition of measure becomes important. Now, in the last video, part 2, I talked briefly about congruent versus equal. Here we go again. So when things are congruent, they are the same size and shape. All right, that is the definition of congruent. Same size, same shape. But if the thing is congruent, if you have two segments, say, that are congruent, or you have two angles that are congruent, then they also have the same measure. We went over that in part 1. So congruency symbols are labeled off of these tick marks. So what this means in this first picture, in picture A right here, is that EF is congruent to HG. Now, if ever you have more than one thing in the picture, so in picture A, I have 2 sets of segments. The tick marks tell you what is congruent with what. EF and HG only have 1 tick mark, so they are congruent to each other. Whereas AB has 2 tick marks, so it is congruent to the only other segment that has 2 tick marks, which is CD. All right, and the same thing goes for picture B. Angles have the exact same rules, except instead of tick marks, we kind of have these little curve thingies. So if I were to have 2 other angles, and let's say we have this angle, and then we have this angle, and I wanted to say those 2 are congruent and they're in the same picture as picture B, I would put 2 little tick marks. That way you can tell the difference between the first set and the second set. So for these, in order to name these up here, the top ones that they already gave you, you would say that angle A is congruent to angle B. Now, one more time, the biggest difference between congruent and equal is that congruent is size and shape, and equal is numbers. And you can even actually see it in the symbols. All right, so equal is just 2 lines. This equals this. It has the same number. They are the exact same measure. Congruent, we haven't really gotten to the measure on congruent. So let's say these 2 angles up here, A and B. A and B are both congruent, which means that if A is, let's say, 40 degrees, because angle A is congruent to angle B, then we know that angle B is also 40 degrees. And therefore, angle A is equal to angle B. And again, this may seem obvious, this may seem redundant, but this is what geometry is, especially this first chapter, is explaining why the simple and obvious things are true. This becomes more important later as we get into proofs, and you're told that something is congruent, prove that it's equal. Or you're told that these 2 angles are equal, prove they're congruent. And that's where this conversation becomes relevant. But always remember, congruent is size and shape, equal is number. All right, so you probably know what these 3 angles are: acute, obtuse, and right. So I'm not going to spend a whole lot of time on this slide. If you are confused, want me to go over it, let me know. The only thing I'm going to say is about right angles, or not the only, but the biggest thing, right angles. Right angles have to have this box. All right, you have to be told the angle is right. If you're not told the angle is right, then you cannot assume it's right. You either need to see the box or you need to see 90 degrees in there somewhere. Okay, the reason is there are a lot of problems where you'll have something that looks like this, and a very common mistake is a student will look at this and say, oh, those are two 90-degree angles, when you don't actually know that. This could be 89 and this could be 91. So before you say the angle is right, please make sure you have done the math or that you see a little box in the corner that tells you it's right. I'm going to add another angle to this, so there are 4 types of angles. This one is known as the straight angle. Okay? The straight angle is literally a line. All right, and it equals 180 degrees exactly. So you probably could have figured it out, but there's the definition just so you can have it in your notes. Now, when two angles are touching, when they share a common side and when they share a common vertex, this is known as an adjacent angle. As we get into the more complicated pictures, there will be several angles going on. The angles that share a common vertex and a common side are adjacent. So in this first example, I'm going to call it example A, angle 1 and angle 2 are adjacent, as it says up here in the top. Okay. Angle 2 and angle 3, or angle 1 and angle 2 are adjacent in picture number B, or picture letter B. Okay. Now over here, in both of these examples, these are non-examples of adjacent angles. What it means is if you are looking at, I'll use different colors so you can see, if you're looking at angle ABC, it is not adjacent to angle 3 because angle 3 is inside of the bigger angle. Okay, so you can't have an angle inside another angle. That's not adjacent. And then over here in this other picture, they don't share a vertex. They need to share a vertex in order to be adjacent. Moving on, we have the angle addition postulate. Now this angle addition postulate is the exact same thing as segment addition postulate, only for angles. Again, it is the part plus part equals whole. So the x piece plus the y piece equals the whole angle. Now the important thing to remember on this one and where things can get confusing is when we have the complicated pictures. When you have a picture where there are multiple angles in here, you need to remember that for any one of these two angles could be the big angle. And what I mean by that is that this is a big angle. This could be a big angle. I'm running out of colors. This could be a big angle, and then you have the really big one right there. Okay? Anytime an angle includes another angle, it could be considered a bigger angle. And so you could use the angle addition postulate on that. Now when you're solving these problems, you solve them just like you would for the segment addition postulate. I would advise you to draw the picture and then solve from there. So we have that ABC is a straight angle. A, B, C over here. And D is any point not on AC. So here's D. I'm going to pause right here and point out the reason why I knew that B was in the middle is because of the rule of angles. B is in the middle over here. It is the vertex. Now this is a straight angle, so it looks a little weird, but B has to be in the middle because it's in the vertex spot. Okay, then I'm going to just draw this line right here, so I have my two different angles. And then you have angle ABD and angle DBC. When they add up together, they equal 180. this is the definition of a straight angle and why it works. So now that we have that explained, let's practice. Again, always, always, always label your work. You're going to hear me say that a lot. I need to see your work. As a math teacher, I almost care more about your work than your actual answers, because you can guess the right answer, but you can only prove that you know what you're doing by showing me work. So in this one, GFZ right here, 38 degrees, ZFE, 2x plus 125, and then GFE, so the big one, is x plus 163. Now that I've labeled it, I can go ahead and put them together and equal it to the whole. And then from here, it's just algebra. So 2x plus okay, and we have x is equal to 0. This is okay. Don't freak out. 0 is still a number. The reason why 0 equals x works is because x is not the measure of an angle itself. So that means that ZEF is 125 degrees. The only instance where you couldn't have this happen is, let's say angle ZFE was the measure of x. The measure of angle ZFE was x. Okay, then you can't have 0 for an answer, because an angle can never be 0 degrees and it can never be negative degrees. So those are the two rules. You can have a negative number equal x, and you can have 0 equal x, but the angle itself cannot be 0 and it cannot be negative. Go ahead and do the second one on your own. And here is your answer. X is equal to 2. Make sure, again, as a reminder, that you are double checking your questions and confirming that all they want you to do is find the variable. Okay, last little piece of information. Angle bisectors, exact same concept as segment bisectors. An angle bisector is a ray or a segment or a line, anything that divides the angle in half, meaning you have two congruent pieces. Okay. Now I wrote in the tick marks, and me personally, I like to stagger my tick marks so that I can see that they're different. Sometimes in the book, you'll see something that looks like this, and it can be hard to tell those are two different tick marks. But I will usually always stagger my tick marks so you can tell the difference. And that is how you show that it's a bisector. You draw in the little tick marks or little curves, and that is how you can clearly show and demonstrate that these two angles are congruent and that BD is the bisector. Now, a congruent statement is when you write out that one thing is congruent to another. So the way I would write out this congruent statement is that angle ABD is congruent to angle DBC. Okay, I have one thing is congruent to the next. This is a congruent statement. You need to know this definition. I will be asking you to write congruent statements a lot in this class. Okay. Go ahead and you can do these last two. I will pause the video now. Make sure you play again to see the rest of the answers, and I will see you in class. Okay, and here are your two answers. So in the blue problem, this first problem, you're told that KN bisects the angle, and because it bisects the angle, the two pieces are congruent. Therefore, you can put those two pieces equal to each other and solve down. You know that you're going in the right direction if the two pieces equal each other in the middle. In the second problem, you're told again that there's a bisector, so same bisector, but you're only given one of the pieces. That's okay because both pieces equal each other. So 2 times the piece you're given has to equal the whole. You know you did it correctly if you can solve for the pieces and solve for the whole, and you get the same answer down at the bottom. All right, that is it. That's the entire PowerPoint. I will see you guys again in class.